This is TRAPPIST-1 planetary system. This planetary system is about 40 light-years from Earth, and it has 7 planets, orbiting an ultra-cool red dwarf star. The red dwarf star has a radius slightly larger than Jupiter, a surface temperature of about 2,293 degrees Celsius, and a mass that is about 9% of the Sun's. TRAPPIST-1 means an ultracool M-dwarf, and it's the smallest class of star. It was discovered in 2016 by the Transiting Planets and Planetesimals Small Telescope. So, let's look at this red dwarf star planets one by one. At first we got TRAPPIST-1b. This planet is situated outside the habitable zone. Having a slightly lower mass, its diameter is almost identical to that of Earth. Of all the planets in the system, this one receives the most radiation. TRAPPIST-1b keeps a very close orbit to its star. One orbit only takes 36 hours, or approximately 1.51 Earth days. This planet is a super-Earth exoplanet. Its mass is 1.374 Earths. Next we have TRAPPIST-1c planet. This planet is similar to Earth in terms of mass and radius, but it is less dense and has less gravity than Earth. This is consistent with a TRAPPIST-1b-like rock-based composition and a dense atmosphere resembling Venus. TRAPPIST-1c is one of the hottest planets ever discovered, with a surface temperature of about 6,800 degrees Celsius. The next planet is TRAPPIST-1d, and is located in the so-called habitable zone. This planet has a radius of 91% and a mass that is 77% that of the Earth. The exact albedo of its surface is unknown. Given the planet's mass, land must make up the majority of its surface rather than being entirely submerged in water. Let's go to the next planet, which is also in the habitable zone. That is planet TRAPPIST-1e. This planet has been found to lack a hydrogen-dominated atmosphere with no clouds, which increases the likelihood that it will have a compact, hydrogen-free atmosphere similar to that of the rocky planets in the solar system. The habitable zone is the area where liquid water is most likely to be found, and TRAPPIST-1f, the 5th planet from the host star, is situated there. This planet orbits every 9 days and is slightly larger in size but less massive than Earth. As we leave TRAPPIST-1e, we are slowly moving towards the next planet, and that is planet TRAPPIST-1h. Despite this planet's orbit being close to its star's frost line, it may contain liquid water beneath an H2-rich atmosphere, that either formed from the beginning, or as a result of continuous outgassing and internal heating. The last planet of this system is planet TRAPPIST-1g. In accordance to a simulation of lava-ocean atmosphere interaction, TRAPPIST-1g is probably to retain a huge fraction of primordial heat atmosphere throughout the first periods of evolution, and therefore currently is most likely to have a thick ocean that is covered by atmosphere with hundreds of bars of abiotic oxygen. This was the TRAPPIST-1 planetary system. Thank you for watching. If you like my content, subscribe to the channel. See you in the next video.